What is computer science? Is it the study of computation? Is it the reverse entropy of information? Or perhaps a corner where a university can quarantine its students who don't shower? What is Factorio? Is it a game about automation? Is it a commentary on the inherently unsustainable growth of capitalism? Or perhaps it's an activity that people in Prague invented because heroin wasn't addicting enough. All these questions and more will be answered in this video. So come, take my hand, and let's go on this journey in this beautiful motherfucker. Factorio. It's the notoriously addictive game on Steam about automation. You crash land on an alien planet, you have to build a rocket to get off, and to do that you plunder all the natural resources and you process them into higher and higher level materials. Software engineering is the end-to-end process of creating and maintaining software applications. Usually that means sites like Instagram or YouTube, but it could also mean things like Microsoft Word or even like the game itself, Factorio. It's a lucrative industry that employs armies of young twitchy neurotics like me to squeeze every last drop of brain juice out of their little skull cavity so that they can stick it in some code and, I don't know, make a website like count views or something. My central thesis is simple. The way that we transport and process materials in Factorio, and honestly any other automation game, closely mirrors the way that information flows in our modern day software applications. This, combined with the fact that both of these are highly centered around automation, means that Factorio and software engineering end up sharing an insane amount of similarities. So between the game about automated industrialization and the industry that brought us automated social gamification, the first similarity we'll be talking about today is, you guessed it, spaghetti. So the reason why we're starting with this topic is because it's one of the fastest, easiest, and best ways to demonstrate exactly how similar these two things are. If you're a Factorio player or a software engineer, both of you are extremely familiar with the term spaghetti. And if you're neither of those, I've put together a completely sane, normal analog as to what that is. So we're gonna roll that clip now.
This is Isabel, and this is Lucy. Isabel wants to call Lucy, so being the great hypothetical friend that you are, you set up a phone line between them so they can call. Oscar hears about this and wants to be connected to Lucy as well. Now, luckily, he lives in a really convenient spot that's right next to the phone line anyways, so you can just plug him right into the network. And this is where the fun starts, because now Victor, Edward, and Tim live in the area and want to be connected to everyone on the network, but they're only kind of close to the phone line and not close enough to just hook in. So, do you redo the current network into a sensible grid system with directional hierarchy? No, of course not. You just curve that phone line around, do a little bit of squiggling and pushing here, and just extend that bad boy, and you're good to go. Okay, now let's really crank things up. So the rest of the neighborhood joins in. Wendy, Olivia, Alice, Nancy, David, Alan, Hannah, Anna, Luke, Frank. I don't even know if that was enough names or if that was too many, but anyways. Now you got all these complications, because like Wendy wants to call David, but doesn't care about Nancy, so she doesn't need to be on the network per se, but then Olivia wants to call Nancy, so they need to be connected, and Alan actually went out with Hannah. Now you gotta switch that around so that they're in the same network. And before you know it, you've made a bunch of spaghetti. I mean, it's always been spaghetti, but like now the spaghetti is more spaghetti. You get what I'm saying. And if you're thinking, okay, those gummy bears are really cute because they grew on me, but is this really relevant to Factorio? Well, guess what? Here's the actual Factorio image I base this off of. That's right. You can't say I don't put effort into these because I do. Also, those gummy bears lived happily ever after to a ripe old age and died peacefully in their sleep.
Suckers. Oh. It's not what it looks like. Anyways, let's cut to the chase. So this is what spaghetti looks like in Factorio, and this is what spaghetti looks like in a microservice architecture diagram, which is a fancy word for saying a pretty picture that we use to describe our systems. In fact, I would just argue that you can replace any of these gummy bears with just random AWS services like AWS Kabuto, Pangoro, or Lairon. Those are Pokemon, by the way. And you'd effectively have a microservice architecture diagram. The reason why we're starting with this, and what I absolutely love about this similarity, is that to the best of my knowledge, both communities, so the Factorio community and the coding community, have, I feel like, independently and individually come to the same conclusion that this is the term we use to describe a very specific type of pattern. Okay, now I hear what you're saying. You might be screaming at your computer screen right now for one very obvious reason. Spaghetti is great. We love spaghetti. You can eat it on a train, you can eat it on a bus, you can eat it on a segue to our next section, code tracing. Huh. We're definitely not producing enough blue circuits. I wonder why. Oh, yeah, we're not producing enough red circuits for the blue circuits. But wait, why are we not producing enough of these? Yeah, that makes sense. Yeah, not enough green circuits for the red circuits, which are for the blue circuits. But wait. Oh, God. Right, we don't have enough iron plates. What we've done here is what I'd argue the exact same thing as code tracing. And just to clarify, like, you could call this anything. Code tracing is just because it sounds better in the title, but like, you know, people call it like debugging or just figuring out the problem or like looking at the stack trace, right? And what it is exactly what you saw. You have an issue and you have to follow your little breadcrumbs that you wrote when you were just like diseased and sad. And the worse that those breadcrumbs are in a line, the harder it is, the more annoying it is to figure out. If everything's in like a perfect little grid, then it's a lot easier. This also brings me to like a sub point that I want to talk about, which is the topic of readability. Story time. And the first thing that comes to my mind whenever I was thinking about this was the story of when I was an intern at insert big tech company here, like 2 summers ago. And I was so proud of writing this piece of code that was like this recursive structure that could take any length array of any different lengths arrays, and it would give you all the permutations of all the items. And I was so stupidly proud of this because I thought it was like the best thing that anyone had ever written and that I had written. And I got even more stupidly proud of it when it got approved and the code went through and the code is in the code base now. And then I came back a year later as a full-time employee, and I immediately realized why it was so dumb of me to be proud of that. And in fact, why it's actually insane that the code got approved in the first place, because I was looking at it and I was like, I have no idea what this is. And it's not because previous me was smarter, it was because it was just a really messy piece of code, right? It was something that sure might have been smart, but if nobody can read it and understand it, when it breaks, it's just broken forever and it's useless. Never mind somebody else, like a different engineer coming back and doing it. Will you, like your own human being, 2 days from now, will you be able to look at this and like work on it and fix it, right? Because if you don't know what's going on, God knows other people are not gonna know what's going on. And I think this really underscores my point about readability, where the microseconds that you might get from making an algorithm that much more efficient or that many less lines is almost never worth the pain and time wasted that you will have in the future or somebody else will have in the future trying to understand it, improve it, fix it, or change it. And I want to acknowledge there's obviously a lot of caveats here, right? If you're working at like a high frequency trading shop, the nanoseconds that you save are probably worth billions of dollars to your company. In that case, yeah, you write whatever you can to make the most efficient possible trading algorithm so that you can earn that money for your company. Another caveat is like maybe there's just literally no other way, right? There are genuinely sometimes where you need to have this like really crazy algorithm or thing to do what you need it to do. Or maybe you're playing Factorio and there's just like a giant lake in the middle of your base for some reason. Like, yeah, I get it. You gotta do what you gotta do. Now that we've identified that the issue with our systems is not enough processing because we've done the code tracing, how do we fix this? Well, that brings us to our next subject, which is scaling. What am I doing? Okay, so I am super excited about this chapter, and the reason why is because this idea, the one I'm about to talk about, is the reason why I came up with this whole video essay. This is the inception of all the similarities I started to notice. So you're gonna wanna stick around, I promise, because the very end where, you know, like everything comes together, oh, it's beautiful. All right, so let me drop some tech knowledge on you if you're not familiar with the internet. The internet is just other computers that we have somewhere else underground or just in giant warehouses. What we do is we link up all those computers, and some of these computers' only job is to take your computer's traffic and send them to other computers. And those computers we call servers because they serve information to traffic. Now, bear with me here. This is the really cool and crazy part. Those servers, those computers, those machines, each one of those can be seen as one of these branches. And the way that we scale then becomes the exact same way we scale in Factorio. Let me break it down. Imagine each one of these little smelting machines as like a CPU, right? This branch becomes a computer. And so when you have more of a processing need for higher traffic, the way that we can scale up this server is by 3 axes. The first axis of scaling, right, is we have this branch, we have this server, and we can just add more furnaces, we add more processes, right? And so what happens is we have the server, we have a computer, right? And we just make it bigger. We make it taller. And this is what we call vertical scaling. See, vertical scaling. Isn't this cool? The second axis of scaling is we can go this direction. That's right, you guessed it, horizontally, and we can add more computers. And that's what we call horizontal scaling in software engineering. This is so crazy. Like, does anybody else see this? This is a computer. These are processors. We literally scale vertically to add more processors into this one computer, or we add more computers and we scale horizontally. You know how to vertical scale and horizontal scale now. And now there's a third axis that outly scaling. Yes, I made this up. Yes, I could be missing some axes. If you're smarter than me, yes, you should be commenting right now. What you can do is you can input speed modules into these furnaces. And what that does is it doesn't change the amount of furnaces, it doesn't change the amount of branches, it makes the furnaces themselves faster. And for me, what that means in this analogy is that the server, the computer that we have, we keep the same amount of CPUs. We keep the same computer, but we swap out the CPUs for faster ones. We're not adding them, we're not adding another computer, we're just making them better. And those are the three axes of scaling that are the exact same thing as computer science and software engineering. Isn't that crazy? Like, does anybody else realize how cool that is? That like, you're just playing a game and little did you know, you've learned like a high value skill that a lot of people use on like a daily or weekly basis to make sure that giant websites like Google, Amazon, and Facebook don't just crash. That's crazy. And so now you know what scaling is, we can start to talk about the really cool stuff, which is traffic and traffic shaping. So what better way to get into traffic than via Segway? Oh God, somebody send me to the nearest hospital. All right, traffic shaping. Now there's two subsections I want to talk about in this chapter. The first one is auto scaling and the second one is load balancing. And you're going to want to stick around because this plus the next chapter is going to just totally put together this beautiful image of how the internet works and how you yourself can become a software engineer. So let's start with auto scaling because we just talked about scaling. And you're going to love this, Factorio players. So you see this thing that we were just working with. But you know what software engineers have done? We have automated the automation. In Factorio terms, we've hooked up wires and sensors to the inputs and outputs, and then we can detect if we need more machines depending on how much is coming in. When there is a need for more processing power, it automatically adds more computers to our server base, or it swaps out a computer for a different one. That's all done now without any human intervention. So for example, Facebook usage goes up because your mom is trying to talk to me. Oh, God damn it. God damn it. Can't keep doing this. Our second subsection of this chapter is load balancing. And load balancing is one of those other things that Factorio and software engineering share as the same term. In Factorio, you have this beautiful guy who load balances. You got your 2-to-1, you got your 3-to-3, you got your 4-to-1. I'm gonna hate animating this later because that's just a lot of random pictures I have to get. And it's exactly what it sounds like. You have a set amount of input and you're trying to get the correct amount of output so that it's even among whatever your processing is. So in the software engineering example, these are our servers and the incoming traffic that we're getting, we want to balance the load evenly across all of these so that this computer isn't getting a lot more than this computer unless this computer happens to be bigger, right? And this is what's really, really cool. Go onto like AWS and search up AWS auto scaling or AWS load balancing, and there are services that are literally named that to do exactly what we said. And furthermore, you can go to like Google Cloud, you can go to Microsoft Azure, I can guarantee you they have the exact same services. This is a widespread thing that just people do nowadays. That's a very common practice. What I think is really awesome about this is that this is like public knowledge, right? Like this isn't some crazy top secret like thing that I know that like only the Illuminati and people who can do this dance, you know, know. This also gets to the core of what I said at the very, very beginning of this video, which is that these things are so alike because they also revolve around the idea of taking things that used to require manpower and automating them away because we are lazy and will do anything to not do a job, even if it means that we ourselves will be out of one. And this thing that took us decades to learn how to do to keep the internet running smoothly, more about that later, is something that you've just been naturally doing with your good Factorio instincts, playing games at home with your friends. Moving on to the next chapter, I don't have a good segue for this, so I'm just gonna keep rambling until I get cut off. Okay, upstream and downstream dependencies. This is their last, but I would argue maybe one of the most important points that I have to make in terms of keeping the internet running. And so I'm really excited to, at the end of this, show you how this chapter and the previous chapter kind of conglomerate into this perfect, beautiful image of why websites go down or how we keep them running and how maintenance works in general. So let's get into it. So sticking with this analogy that the materials and the intermediary products in Factorio are the exact same thing as the information we're handling in software engineering systems, we can see here that there is in fact a general flow direction where we have lower value materials / information being processed into higher value materials / information. So in Factorio's case, we just started out with iron ore and coal and copper ore, and we get to extrapolate and mutate all of this stuff into really high value things that we can then deliver. Now this becomes really cool when you put it into the context of traffic shaping, because traffic shaping then affects your downstream services, right? So if we take a look at our whole iron service, which we've upgraded to now be able to intake more iron ore and output more iron plates, you have to then think, okay, but in our entire system, there must be some other service that's taking this output, right? That's going downstream. So you trace these iron plates downstream and you realize now that you might be overloading other systems, or in this case, they might just be backing up. Now, here's a slight difference between Factorio and software engineering, where in Factorio, it's okay if stuff backs up. But in software engineering, if these things back up, that means that people aren't getting to your website. You're losing money, and that's bad because capitalism good, and we need more of everything, and everything must grow, and the factory must grow, and oh my God. And this is the lifeblood of basically all software applications, is we are taking some sort of input information from the user, like your birthday, your password, what kind of cat food your cat likes, and we are spitting back out information either to another service or directly to you. And you see how beautiful this is in that it's the same thing? The reason why you want to have this in your sort of like software engineering back pocket of lexicon is because a system up here will always impact a system down here if they're connected in some way. And this brings us to the idea of contracts or schemas, which is just a fancy way of saying the format in which you pass information between these things. So if I have my upstream iron intake here and my output is just like 3 full belts, right? Then the downstream dependency has to take in 3 full belts, or maybe 1 belt, but you have 3 of those services. The point being here that the way that this thing outputs stuff will impact how we design the intake here, right? Because this upstream service impacts this downstream service. Now, I said earlier that the auto-scaling groups I mentioned earlier that autoscaling, load balancing, and now upstream and downstream dependencies, these 3 ideas together would form something really cool. And I'm here to give you that right now. Whenever anything goes down ever, right? And all of us, including me, think, oh my God, how is this possible? I just want to log into Apex Legends. I just want to log into Facebook so I can talk to your mom. All of us are thinking the same thing, which is like, how is this possible? You have like $1 bajillion and just warehouses and farms filled with these rocks that we've taught to take in electricity and do thinking for us, right? And yet somehow I hit the button to go to your website and the website can't do the thing. What is this? How is this? Well, now you kind of understand where the different fault lines lie. You could maybe have scaling issues where you just don't have enough throughput, and therefore all of these servers are just clogged up and you can't get people through. You could also have load balancing issues where you're not properly balancing between these 3 servers, and so all of them are just trying to fit through this one server. You could also have upstream or downstream dependency issues, where let's say one of these things goes down because your friend decided to nuke your base, Patrick, and now you just don't have any iron processing. And so everything downstream from that is impacted because they can't get the information they need. And this is what's just so mind-blowingly cool about this. And I know I keep harping on this, but I have to repeat it. If you're a Factorio player and not a software engineer, you already know all these concepts anyways. I'm just rehashing it to you in a different format with different words, but it's the exact same concept. So you've been playing Factorio for anywhere from 100 hours to 10,000 hours, and just been sitting there playing games with your friends, And you know now how the internet works and how services can go down and how to structure systems that are robust, self-healing, that can serve millions of traffic so I can finally get on Facebook and talk to your mom. So yeah, I mean, now you know kind of like everything you need to know about. No, that's not true. That's not true at all. No, okay, so here's the deal. I realized halfway through writing all the scripts that there's actually too much to talk about, okay? And let me break it down and just level with you. There's two big topics here, and we only covered one of them. So originally I was thinking there's two different types of software engineering in terms of two different types of services you can make, or I guess I should say programs. You can create a monolithic program, right, which is just one big blob, or you can create stuff with service-oriented architecture. And that's what we've been talking about, where you break it up into little pieces that all talk to each other, right? And this is where I need your help. I want to make another video, but I don't know if I should. I don't know how to make it better, and also I just don't know if it's worth the time and effort. So if you could comment below about what you think, if you want more of this, or if you want to like or even dislike, just give me feedback. Subscribe if you want to see the next one if it comes out, and that would be absolutely amazing, and I'd really appreciate that. I know that this is cringe, but thank you. Anyways, thank you so much, so much for watching the video. I'm gonna put up some fun little cute videos, I guess, while I do the outro here. Check out the Patreon if you want. Links will be either here in the description below. I also will have like a Twitch link and just a bunch of other socials if you really want to throw me a bone. I don't have like anything on the Patreon right now, but like maybe I'll put up like a director's commentary or something if this video gets big. Anyways, yeah, thank you so much. All right, peace. Love you. Bye.